Okay, so I'm going to go over this argue from evidence about gravity assignment with you. It's a little bit tricky to do if you don't have a teacher around to answer questions and help give you instructions. So this video will help you so that you'll be able to be successful on the assignment. So first of all, make sure that you click on this link here and it'll open up the pieces of evidence into a new tab. And then also, we've got such a tiny sliver of the Google Doc down here. It helps if you click on this link right here. So click on both of these links and it'll open up the Google Doc into a new tab, and then also the Google Slides of the pieces of evidence into a new tab. I've already typed my name and my class period on here. I'm just imagining I'm from first period. So let's go ahead and start answering question 1 together. It says, when an object has more mass, what happens to the force of gravity that it is able to exert? So something with more mass, does it have more or less or the same gravity? So let's look at our pieces of evidence to figure this out. So first of all, we have item 1 is a table. It has the mass and the gravity of a bunch of different planets plus our sun. And first of all, let me explain to you how to read this, because we've got some scientific notation on here. Like, check out the mass of the sun. It says 1.991 times 10 to the 30th. That is just an easy way to write a really big number. So 1.991, and then the times 10 to the 30th part just means that you move the decimal place 30 times to the right. And that adds a ton of zeros on the end. In fact, it adds 27 zeros on the end of this number. So imagine I'm moving it 30 times, 1, 2, 3, 4, and I would keep going 30 times, and it would add, it would add all these zeros on the end, etc., right? So it would be a really, really big number. That's the mass of the sun. But this is just a faster way to write it right here, okay? Let's look at another one, like the one at the bottom, Pluto. 1.15 times 10 to the 22nd. So that would be the same thing as 1.15, but then you move the decimal place 22 times. So that would add like 20 zeros onto the end. So that's also a really big number. But it's not as big as the mass of the sun, because notice that Pluto is just 10 to the 22nd, but the sun is 10 to the 30th. So the sun has a bunch more zeros on the end of its number than Pluto does. So the mass of the sun is a much bigger number than the mass of Pluto. Okay, so that's how you read that times 10 to the 22nd or times 10 to the 30th. You just scoot the decimal place over and add a bunch of zeros. So remember, we're trying to find out an object with more mass, what will happen to its gravity? So let's figure that out based on this table. Let's find out which of the planets or stars on here has the biggest mass. And if you look at the mass on this whole table, the one with the biggest mass is going to be the sun. Let me erase all my drawings really quick so that, here we go. Okay, the biggest mass is going to be the sun because it's times 10 to the 30th. None of these other ones are times 10 to the 30th. They're all less than that. So they're going to have less zeros on the end, and they're going to be smaller numbers. So the sun has the biggest mass. Now let's see what its gravity is like compared to the other ones. Has 293 meters per second squared of gravity. And in fact, that's way bigger than all the other ones on the table, right? So the sun has the biggest mass and the biggest gravity. That makes me think that things with bigger masses have more gravity. But just to double check, let's find which one of these planets has the smallest mass and see if it also has the smallest gravity. So go ahead and look at all the numbers here. You can pause it if you want to. And what I'm seeing is that Pluto has the smallest mass because it's 1.15 times 10 to the 22nd. That has less zeros than all the other ones, right? So that's the smallest mass. And then let's look at its gravity compared to the other ones. It also has the smallest gravity. So the thing with the biggest mass also has the biggest gravity, and the thing with the smallest mass also has the smallest gravity. So more mass equals more gravity. So now I'm going to exit out, if I can. Hopefully this works. And I'm going to go type that into my Google Doc. So it says when an object has more mass, what happens to the force of gravity? I'm going to say objects with more mass have more gravity. And I'm going to delete some of this line so that it'll look better. See how that looks nicer when I delete that? Now it says, which of the pieces of evidence support your answer? Circle all that apply. I just found that answer in item 1. So it's kind of hard to circle things on Google Docs, so let's bold and underline it instead. Like that. So item 1 is where I found that evidence, but I'm not quite finished. First, I want to look at the other pieces of evidence and see if any of those also support it. So we already said that item 1 supports it. Let's look at item 2. This one is showing the speed. Oh, whoops. Hold on, I gotta turn on my pen first. Here we go. This one is showing the speed of the planet and its distance from the sun. That doesn't really tell us about mass and gravity. So we're gonna say item 2 is not gonna help us with that question. Okay, now let's look at item 3. If I can get there, come on. There we go. Item 3, okay. So it's showing us, this graph is kind of hard to read, but here on the y-axis we have gravitational force, and then on the x-axis we have distance. So it's showing us gravity versus distance. But remember, the question was asking about gravity versus mass. So item 3 isn't going to work for this question either. Let's go ahead and look at item 4. So we can see the Earth and the Moon. They have a stronger gravitational force than a ruler and a pencil do. And what you know about the Earth and the Moon is that they also have more mass. So what item 4 is showing us, that more mass has a stronger gravitational force than things with less mass. And that totally proves what we said as our answer in question 1. So I'm going to go ahead and go back again to my Google Doc. And that was item 4 that proves it. So I'm going to highlight item 4, bold it, and underline it. There we go. Now we just have 2 more pieces of evidence to look at. I want to look at 5 and 6. So item 5 is showing us that 2 planets with a... Whoops. Sorry, I'm having issues with my stylus. Hold on. I got to turn on my pen again. Here we go. It's showing us that 2 planets with a small mass, and they're close together, so they have a small distance, have medium gravity. And it's showing that 2 planets with a large mass and a small distance, so they're close together, have large gravity. And then down here it's showing that 2 planets with a large mass that are far away have small gravity. So that's kind of showing us mass and distance and how they both relate to gravity. So this would work as our answer for question 1, because it is showing us that more mass equals more gravity, because we can see these first 2 have the same distance apart, well, pretty much the same distance apart from the middle of them, but the ones with the larger mass have the larger gravity. So that would work. Let me exit out again. Whoops, come on. Technical difficulties here. Switching back and forth. Okay, item 5 works. And then let's look at item 6, last one. Okay, so this one is showing us that the same guy standing on Earth and standing on the Moon, he has different weights on Earth than he does on the Moon. And the reason for that is the Earth has more gravity than the Moon. Check out this gravity arrow. On Earth, it's way bigger than the gravity arrow on the Moon. That's showing that the Earth is pulling harder on this guy, which is why he weighs more. Look, he weighs 200 pounds on Earth, but only 33.2 pounds on the Moon. Based on what you know about Earth and the Moon, you probably know that the Earth has more mass than the Moon. So that totally supports our answer that things with more mass have more gravity, because this is showing us that the Earth, which has more mass, has a bigger pull of gravity on this guy, and he weighs more on the Earth than he does on the Moon. So we can also highlight item 6 on our Google Doc. So I'm going to switch back over to my Google Doc, highlight item 6. I just lost my internet connection. Let's imagine that I highlighted item 6. So for number 1, I would have bolded and underlined item 1, 4, 5, and 6 because they all support my answer to number 1. Okay, so let's go ahead and look at number 2. And I'll just kind of get you started, but I'm not going to go through all the evidence this time. So number 2 says, what objects have a gravitational force? So you would start, just like we did last time, by looking at item 1 and see if that answers the question, which objects have gravitational force? Well, this is showing us that planets and stars have gravitational force, right? But that doesn't really tell us like exactly everything that has gravitational force. Item 2 is showing us speed and distance. That doesn't really help us answer the question. Item 3 is showing gravity and distance. Also doesn't really help us answer the question. Item 4 is showing us that things like planets and moons have gravity, and things as small as pencils and rulers also have gravity. This would be good evidence to answer that question, because it's showing that anything that has mass also has gravity, from things as big as planets and moons to as small as your pencil. If your pencil has gravity, you might think, why doesn't it attract things towards it? It's because your pencil has such a small mass that it doesn't have enough gravity to attract things, but it does have gravity. Anything with mass also has gravity. So I'm going to go back to my Google Doc. I don't know if it'll let me type. Oh yeah, I got my internet back. Great. So I'm going to highlight item 6. Okay, so what objects have gravitational force? Anything with mass has gravity, okay? Notice I did my answer in a complete sentence, so make sure you do that too. Okay, and then I used item 4 to support that. But I also need to look, I guess I will go through the other items with you. It shouldn't take us too long. Let's look at item 5 and 6 and see if they support it. So item 5 is showing us things of small mass that have gravity, things of large mass that have gravity. It's really showing us mass and distance, but you could highlight item 5 because it's showing things of different masses all have gravity. So I think that supports it too, just not as clearly as item 4. Let's go ahead and look at 6. 6 is showing us that a man weighs a different amount on Earth and the Moon because Earth and the Moon have different gravitational pulls because they have different masses. You could use that to support it too, but again, it's not as clear as item 4. So item 4 is the most important one to have highlighted here. I'm also going to highlight 5 because I think that one could be used to support it. But I'm just going to do 4 and 5. If you wanted to do more, you can. Just make sure you have reasoning to support why that evidence helps you answer that question, okay? So I think you've got a good handle on it by now. You probably have it figured out how to do this. There's just one more thing I want to talk about, and that is the one that I always get a question on when I do this in class, actually. There's a few that I always get questions on. So let me talk about them really quick because you might wonder this too. Let's talk about number 9. It says, why is there no up or down in space? My students are never quite sure about this one. So if you think about it, the way that is down is the way gravity is pulling you, right? It's toward the center of the Earth is which way down is. But if you're out in space and you're not close to a gravitational field, you're not being pulled by anything. You're not being pulled down at all. So it's almost like there is no down in space, right? So we are familiar with up and down relative to Earth's gravity. But if we're not in a gravitational field, then we don't really have an up and down. It's just kind of like you're floating around everywhere, right? So that would be a good thing to answer for number 9. And then I'll let you find the evidence yourself. Look through those same 6 pieces of evidence to find evidence to support your answer for number 9. For number 10, you don't need to use the evidence pieces from the PowerPoint or the Google Slides. You can just use evidence from your own experience. Have you ever seen gravity repel something? Have you ever seen something like a person all of a sudden go flying away from Earth's gravity for no apparent reason? Probably not. Gravity, I don't think we've ever seen gravity repel. It's an attractive force. So your evidence for that could be your personal experience. You've never seen gravity repel, right? And if we haven't seen it, then we have no proof that it could happen. So, and then number 11, you could answer it either way. So it says, is magnetic force or gravitational force stronger and why? I've had students answer it either way, and the main important thing is that you have good evidence to support it. So sometimes students bring up that the Earth has a magnetic field and a gravitational field, right? So they talk about whether the gravitational field of Earth is stronger than the magnetic field of Earth. I've had students say that the gravitational field of Earth pulls on everything. It keeps everything on the ground. But the magnetic